Hi everybody, in this video we're going to continue with Centripetal Force with our first example. Let's begin. In a circus performance, a stunt of riding a bicycle in a loop-the-loop was introduced. The radius of the circle is 2.7 meters. What is the minimum speed needed to maintain contact at the top of the loop? Let's go ahead and draw our circle. And the radius of this is going to be 2.7 meters. And we are concerned about the stunt while they are at the very top of this loop. So we are going to draw a free body diagram, and this is our object is at the top, and there are only this is an example of centripetal force where the object is maintaining a circular path. There are two forces here that can contribute to the centripetal force. It is the force of gravity and the normal force. The centripetal force is equal to the normal force plus the force of gravity. However, if they're barely maintaining contact with the surface at the top, we're talking about the minimum speed here, then they're barely touching the loop at the very top. So we want to say that the normal force is more or less it's zero. Once we have that, once we say normal force is zero, then all we're left with is the centripetal force is equal to the force of gravity. We can define centripetal force to be mass times the tangential speed squared over the radius of the loop, equaling the normal equaling the force of gravity, which is just mg. All right. You could look at this and see that the mass cancel out. So we never knew the mass of the stuntman. So luckily that cancels out for us. So that's nice. And then we're just left with the tangential speed squared over r equals to the gravity. You might wonder why we don't put the negative sign there. We can actually, but they end up canceling each other out because we have to put the negative sign for the force of gravity and the centripetal force. So if we put a negative sign on both sides, they actually end up canceling out. Moving forward, we have the tangential speed squared equals to rg, radius times gravity, and then to solve for the minimum speed, we just end up square rooting both sides. With that, we have the tangential speed equals to the square root of radius times gravity, radius of 2.7 meters times square root of 2.7 meters times 9.8, and we get a minimum speed of 5.14 meters per second. And that concludes our problem. Thanks for watching the video, and I hope you guys found this example helpful.